Let's take a look at something called compound interest. Let's begin with an example. Sarah is going to invest $1,000 into a savings account, which pays 4% interest compound annually over a period of years. $1,000 is what she's beginning with. 4% is the interest. Let's go ahead and write this as a decimal, since we will have to use a decimal when doing anything mathematically. And annually means per year. What is Sarah going to have when she begins? Well, in her account, she will have $1,000 as she begins, 0 years. After her first year, however, she will have the $1,000 that she started with, plus $1,000 times that 4%, giving her a total of $1,040 after 1 year. Now remember, when looking at exponential growth and exponential decay, which this is appearing to look like, when including the initial total, we can change this to be the amount you started with times your change, which is 104%, because you are keeping 100% of what you started with and just changing it by 4% to the number of years. Taking a look at year 2, she would have $1,040 from her first year, plus taking that $1,040 and multiplying it by the 0.04 interest, and she will have $1,081.60 after 2 years. Remember, we can take this function here and rewrite it again with what she's starting with at 1,000, the amount it's changing each time, and how much time has passed, which in this case is 2 years, and we will also get 1,081.60. What happens if we change the interest rates, or the number of times it is compounded? We need to take a look at a new formula that we'll use for compound interest. Here is the formula for calculating compound interest. Here's what all of these letters mean. A is the amount that you have in your account. P is your principal, or in this case what you started with. R is your rate. In the previous example, that was 4%, or 0.04. N equals the number of times the interest is applied. So if something is quarterly, it's going to be applied 4 times. And finally, T is your total time. Let's take a look at Sarah's example. Sarah and her $1,000, and let's say she puts it into an account where the interest is compound quarterly. That means 4 times a year. How much would she have after 2 years? So again, the key words in the sentence are quarterly, and 2 years. Remember that quarterly means 4 times. Just like you have 4 quarters in a dollar, quarterly will happen 4 times. Again, using Sarah, her P, or her starting point, from our previous example, is $1,000. Her R, or her rate, will remain the same at 4%, and to use that we need to put that in decimal form at 0.04. Her N, how often is that happening, is quarterly, so 4 times. And her T, how long is that happening? Well, that's happening for 2 years. Let's plug this in to the compound interest formula. What will be in her account equals P 1,000 times 1 plus her R, which again use decimal form, divided by 4, which is her number of times it's compounded, all over N, which is 4 times 2. Plugging that into the calculator exactly as written will get you the result of $1,081.60. $82.82. This is what would happen if she had an account that was compounded quarterly. If you take a look, after 2 years, she had $1,081 in her previous setup where she was only getting interest once a year. Now 4 times a year, and she's earned an extra $1. Let's compare 2 accounts and what their balance would be in Sarah's situation after 5 years. One if it was compounded annually, and one if it was compounded quarterly. So taking a look, let's put things that will be the same. We're trying to find out what's in her account. Her principal, or what she's starting with, will be $1,000. Her rate will be 4%, written as a decimal. And then the number of times will change, but the total number of years will be over 5 years for both cases. Now, with N, 2 situations we want to look at are annually and quarterly. Annually means yearly. Quarterly means 4 times a year. So let's take a look at those 2 situations and see which one would be better. Both are over 5 years, so where will she earn the most money? Let's take a look at annually first. Using our formula, what will be in her account, starting with a principal of $1,000, times 1 plus our rate, still the same. And we're going to do this annually, so that'll be once, or once every year. And we will do this once a year for a total of 5 years. Plugging that directly into a calculator, she will earn $1,216.65, an extra $216 from what she started with 5 years later. Let's take a look at her account when her interest is compound quarterly. Again, she's beginning with the same amount. Her rate is still 0.04. Quarterly, her interest will be compound 4 times a year. And again, that's happening 4 times the total number of years, which is 5. Plugging that into the calculator, she will earn $1,220.19. In this case, Sarah would want an account that compounds quarterly, since she will earn more money doing the same thing.